how to read. If you just clicked on a key from your keyboard, you'd only be sending a byte to the CPU. The CPU doesn't know what this is because it doesn't have instructions on how to deal with it. Turns out, our devices also use programs to tell the CPU how to run them. These programs are called services or drivers. The drivers contain the instructions our CPU needs to understand external devices like keyboards, webcams, printers. Our CPU doesn't know that there is a device that it can talk to, so it has to connect to something called the BIOS, or Basic Input-Output Services. The BIOS is software that helps initialize the hardware in our computer and gets our operating system up and running. Unlike the programs you're probably used to running like a web browser or operating system, the BIOS isn't stored on a hard drive. Our motherboard stores the BIOS in a special type of memory called the read-only memory chip, or ROM chip. Unlike RAM, ROM is non-volatile, meaning it won't erase the data if the computer is turned off. Once the operating system loads, we're able to load drivers from non-essential devices directly from the hard drive. In today's system, there's another player for BIOS called UEFI, which stands for Unified Extensible Firmware Interface. UEFI performs the same function of starting your computer as a traditional BIOS, but it's more modern and has better compatibility and support for newer hardware. Most hardware out there today comes with UEFI built in. Eventually, UEFI will become the predominant BIOS. When you turn on a computer, you might notice a beeping from time to time. Our computers run a test to make sure all the hardware is working correctly. This is called a power on self-test, or POST, and the BIOS runs it when you boot up your computer. The POST figures out what hardware is on the computer, so it happens before the BIOS initializes any hardware or loads up essential drivers. If there's an issue with anything at that point, there's no way to display it on the screen since things like the video driver haven't been loaded. Instead, the computer can usually produce a series of beeps, almost like Morse code, which will help identify the problem. Different manufacturers have different beep codes, so if your computer successfully boots up, you may hear a single beep. If you hear two beeps, it could mean a POST error. It's best to refer to your motherboard manual to find out what each code means. Also, you should know that not all machines have built-in speakers, so don't worry if your computer boots without a beep. If it does have a built-in speaker, being able to distinguish what the beep codes mean is an extremely helpful tool when troubleshooting boot issues. One last thing we will discuss are BIOS settings. There's a special chip on our motherboard called the CMOS chip. It stores basic data about booting your computer, like the date, time, and how you want it to start up. You can change these settings by booting into CMOS or BIOS settings menu. It varies on different computers, but usually when you boot the computer, there'll be a quick screen that tells you what button to push to get into the settings. From there, you can change the basic BIOS settings of your machine. In an IT support role, you might interact with the BIOS more often than you think. BIOS settings control which devices to boot to, and in an IT role, you might need to change the settings more often than not. A frequently performed IT task is the re-imaging of a computer. The term refers to a disk image, which is a copy of an operating system. So the process of re-imaging involves wiping and reinstalling an operating system. This procedure is typically performed using a program that's stored on some external device like a USB memory stick or a CD-ROM, or even a server accessible through the network. To access these programs and perform the re-image, you'll need to use the BIOS to tell the computer to boot up from that external device.
The one great constant in the technology industry is its history of change and the speed of that change. So no education is going to give anyone the skills they need for an entire career. You've got to have curiosity. You've got to have a lifetime of curiosity and a dedication to a lifetime of learning, because the tools and technology that we use in this industry are always going to be changing. Great tech skills are really important, but the important thing about a technology is that it serves people and it serves the interests of people. You have to like people, you have to like helping them, you have to have empathy and sympathy for their problems. That is the most important thing. There's no corner of our lives or of industry or of government or of society that IT and technology don't play a role in. And these are skills that don't just help you in your job, but they can help you with every facet of your life. And they're going to be relevant to everything that we do in our lives for as far into the future as anyone can predict. Try this program out. If you can learn this material, if you like this material, then you could have a great career in technology, and don't worry about the other stuff.
Now that we've learned what the computer components are and how they work, we're going to assemble our very own computer, a full-size desktop. Computers are incredibly fundamental to the work of an IT support specialist. They're used in pretty much every aspect of the job. Aside from work, knowing how to build a computer might inspire you to try all kinds of cool stuff. You could custom build a gaming rig to play the most advanced game at the highest settings, or, like me, make a home media server for all your photos and videos. Knowing how to build a computer is a skill that can be useful in lots of interesting ways. Before we get started, let's lay down some ground rules for this ground-up build. Sorry, I couldn't help myself. We should think about electrostatic discharge and try to prevent unwanted static from harming our very expensive components. Have you ever rubbed your socks on a carpet then accidentally zapped someone? That's pretty harmless. But if you do that to your new motherboard, you could completely destroy it. So how do we prevent static discharge? We can go about this in two ways. You can touch an electrical device that's plugged in but not powered on. FYI, you should do this every couple of minutes when assembling a new computer. Another option is to wear an anti-static wristband, like the one I have here. Let me get it. You connect the end of the clip to a non-painted metal surface, like your computer, and then you strap it on to your hands, and voila, you're done. While we're on the subject of anti-static safety, I want to call out that when you buy computer parts, they'll come in anti-static bags to prevent accidental static electricity. Be sure to keep them inside the bags until you need to install them on your computer. Now, let's get making this computer. We'll start by laying down the foundation of our computer, the motherboard. Remember, there are lots of different form factors for motherboards, and you want to make sure the one you purchase fits your computer case. We purchased a full-size desktop case and have a full-size ATX motherboard. On the motherboard, there are lots of screw holes which coincide with the holes in the desktop case too. You want to match up the holes on the motherboard to the holes on the desktop. Once you figure out which holes to use, screw in these standoffs. Standoffs are used to raise and attach your motherboard to the case. In this instance, our case has built-in standoffs. Let's start adding on components. Let's start by adding our components in. We'll start with the CPU, so let's take that out of our anti-static bag. You want to be very careful with these because they're very expensive and you don't want to drop them. Once we've taken out the bag, let's line up the CPU with the motherboard socket. Something to note is this marker right here. This has to align with the CPU socket on the motherboard. Also, don't forget to make sure you get compatible CPUs that fit your motherboard. We have an LGA CPU and an LGA compatible motherboard socket. So let's go ahead and align the correct orientation of the CPU and secure it in place like this. So like mentioned before, you want to make sure that the pointers on the CPU and the socket are aligned, the easy part is putting the CPU in. The fun part is securing this. Just note that when you secure the CPU in the socket, you do need to use a bit of force so it's tightly secured in. 2. Perfect. So now the CPU is secured in the socket. Now that our CPU is in place, we need to add our heatsink on top of it. The heatsink is used to dissipate heat from our CPU. I want to show you some cool things. This part right here, this is what our CPU relies on to stay cool. It takes the heat from there and then uses this fan to blow it out. Before we attach the heatsink, we need to apply an even amount of thermal paste. Let me get that. This is the thermal paste. Thermal paste is used to better connect our CPU and heatsink, so the heat transfers from one to the other better. To get started, apply a dab of thermal paste and spread it evenly with a flat object. Let's do that on our CPU right here. So first thing that you want to do is slowly apply a slight dab on the CPU, like so. Then with a flat object, apply the thermal paste evenly throughout your CPU. So you go halfway right here, halfway right here, halfway right here, and then halfway right here. Just make sure that I spread evenly throughout the CPU. You may have to do this multiple times to get this correct. Okay, so once you have that in place, you're going to take your heatsink and then you're going to press it against the CPU. And something to note is these screws right here, they align with the CPU socket, so that could guide you while you put the heatsink on. Great. Once you have all 4 sockets aligned, go ahead and get your screwdriver and then tighten down the sockets. So one thing to do is to make sure that you screw opposite sides first, so you know that the heatsink is attached securely. So one thing I like to do again is just to kind of go over my screws to make sure everything is tightened securely. Great. Now that our screws are tightly on and our heatsink secured to the CPU, you have to plug the small legs to the motherboard. This is important because this is what controls the fan speed via the motherboard. Perfect. So now you've fully installed and connected your CPU to the motherboard. Let's install